Welcome to video lecture number 32, page number 82. Question number 16. In the depression of freezing point experiment, the options given A, B, C, D go through. Vapor pressure of the solution is less than that of the pure solvent. It is a right statement because in the solution, the solute particles obstruct for evaporation of the solvent. So, A is a correct statement. B, vapor pressure of solution is more than that of the pure solvent. That is going to be wrong. Only solute molecules solidify at the freezing point, which is also wrong because solute is a non-volatile component. Option D, only solvent molecules solidify at the freezing point. That is a right statement because solvent molecules solidify. Clear? So, for the question number 16, the option is A, in which A and D are the correct statements. Hope it is clear. Coming to question number 17. Consider the following pairs of solution which will be isotonic at the same temperature. The number of pairs of solutions is or are that has been given for isotonic solution. C1 equal to C2. So, the concept what we use is pi is equal to I C R T. Clear? So, where I is number of particles, C concentration, R and T are going to be constants for both the pairs. Clear? So, going with substituting for the option A, pi NaCl is equal to 2 particles, concentration 1. So, it is going to be 2. Pi for urea is equal to 1 particle, concentration 2. So, it is going to be 2. So, like this they are isotonic. Clear? Similarly, in the B option, pi CaCl2 where 3 particles, concentration is 1. So, 3 pi for KCl, particles 2, concentration 1.5, it comes out to be 3. So, isotonic. Then C, in that pi for AlCl3, it is going to be 4 particles 1.5, which comes out to be 6. Pi of Na2SO4, 3 particles 2 M, so 6 isotonic. Similarly, in D, pi of KCl 2 particles into 2.5 equal to 5. Similarly, pi of Al2SO4 thrice, it is 5 particles 1, so it is 5. So, this is going to be isotonic. So, all 4 pairs of solutions are isotonic. Going to the question number 18. 2 solutions A and B are prepared by dissolving 1 gram of non-volatile solute X and Y respectively in 1 kg of water. The ratio of depression in freezing points for A and B is found to be 1:4. The ratio of molar masses of X and Y is, it has been given. So, 2 different solutes in the same mass of water and the Kf is going to be same. So, you can write as 1 they are in the ratio of 1:4. So 1 for the x, I am writing 1000 by 1000 into 1 by mx into kf. It is based on the formula delta Tf is equal to 1000 by W into W2 by M2 into Kf, where the W mass of the solvent, W2 and M2 refer for the solutes. Clear? So now I am writing for the Y, which has the ratio of 1:4. So this is for 4y, 1000 by 1000, 1 kg it is. So 1 by the mass of the y and then kf. So in this, if you are going to make these one side which are the same for both, you can write 1 mx is equal to 4 my, which means mx by my are going to be 4 by 1, which is nothing but 1 by 0.25. Clear? Which is nothing but the option B. 4 by 1 is actually the answer. 1 by 0.25 is the given option in the the answer. So option B is going to be the correct one. Then coming to the question number 19, a solute A associates in water. Assume it as dimerization. When 0.7 gram of solute A is dissolved in 42 gram of the water, it depresses the freezing point by 0.2 degrees centigrade. The percentage association of solute A in water is. Clear? So here the depression 0.2, which is equal to 1000 by 42 into 0.7 gram of solute. Clear? And its molecular mass is not given, consider it as 93. So the data here, molar mass 93. Okay, then into 1.86 into I. Clear? When you calculate for I from the formula, clear, which is 0.2 into 42 into 93 divided by 1000 into 0.7, which is equal to 0.6. So this is I. Clear? You have for association the formula I is equal to 1 plus 1 by n minus 1 alpha, which means 0.6 equal to 1 plus half minus 1 alpha you have to calculate. So when you calculate alpha from this, it will be 0.4 into 2, which is going to be 0.8. Clear? And alpha percentage of association 0.8 into 100, which is going to be 80%. Clear? So this is going to be option D. Clear? Then coming to the question number 20. Boiling point of 2% aqueous solution of a non-volatile solute A is equal to the boiling point of 8% aqueous of a non-volatile solute B. The relation between molecular weights of A and B. So similar problem you have solved earlier. There it was the freezing point, here it is boiling point. That's all. So delta TB is equal to, you have formula 1000 by W into W2 by M2 into KB. Clear? So for the solute A, delta TB for A when you write 1000 by 100 into 2 by MA into KB. Similarly, for the B solution, delta TB is equal to 1000 by 100 into 8 by MB into KB. So similar terms, if you are going to make it one side, clear? So you can write 2 by MA equals 8 by MB, which means 2 MB is equal to 8 MA, or MB is equal to 4 MA, which is nothing but option B. I hope it is clear. Going ahead with the 21st question. Which of the following 0.06 m aqueous solution has lowest freezing point? The lowest freezing point is exhibited by the compound which has more number of particles. So it is option B, because delta TF is proportional to number of particles. So here Al2SO4 thrice has 5 particles, clear, which is higher than any other option there. I hope it is clear. Going ahead with the question number 22, which is the similar one. Which one of the following 0.10 m aqueous solution will exhibit largest freezing point depression? So here glycine, hydrazine, glucose are the covalent compounds or the non-electrolytes, whereas KHSO4 produces 2 particles. So the option B, KHSO4, is the right answer. Is it clear? Then going ahead with question number 23. A set of solution is prepared using 180 gram of water as a solvent and 10 gram of different non-volatile solutes ABC. Clear? The relative lowering of vapor pressure in the presence of these solutes are in the order. They have given the molar mass of A 100, B 200, C 10,000. So RLVP, relative lowering of vapor pressure, P naught minus P divided by P naught equal to W2 by M2 into M1 by W1. So where M2 molar mass of the solute is inversely proportional to RLVP. Here C has got the highest molar mass, so least vapor pressure. Clear? So the option is going to be C, where A greater than B greater than C. I hope it is clear. Since molar mass is highest, relative lowering vapor pressure is least. And the order is A greater than B greater than C. Okay. Coming to the 24th question. The size of a raw mango shrinks to a much smaller size when kept in a concentrated salt solution. Which one of the following process can explain this? Very simple question. The answer is option A, which is osmosis. It is because always the osmosis takes place from low concentration to high concentration solution. Clear? Then question number 25, little a sort of correction is also there, small one, and also you should know how exactly the problem is being solved there. Understand? Okay. The freezing point of a diluted milk sample is found to be 0.2, where you have to make it as minus 0.2. This is the correction. While it should have been minus 0.5 degree centigrade for pure milk. How much water has been added to pure milk to make the diluted sample? Clear? For pure milk, delta TF is nothing but 0 minus of minus 0.5, which is going to be 0.5. For diluted sample, 0 delta TF equal to 0 minus of minus 0.2, which is going to be 0.2. Clear? Then delta TF is proportional to, or it is what we say, it is equal to M into Kf, where M number of moles of solute, which is nothing but the milk protein here, okay, milk protein, which is same for both milk, pure milk and diluted milk, divided by mass of solvent. Clear? In this case, delta TF is inversely proportional to mass of the solvent. Mass of the solvent, which we say it is going to be for W solvent. Because the milk protein solute is constant, by diluting the molality has changed, so only it has to be inversely proportional to mass of the solvent. Clear? So suppose you consider WP, amount of water in pure milk, amount of water in pure milk, and WA, amount of water added, then you can write delta TF pure divided by delta TF diluted equals WP plus WA divided by WP. Note, it is inversely proportional, pure proportional to inversely proportional WP, delta TF diluted inverse WP plus WA. Clear? So which you can write it as 0.5 by 0.2 by 0.2, or you can write 2.5 equals 1 plus WA by WP. You can cross WP by WP becomes 1 and WA by WP I have written, or you can write WA by WP is equal to 2.5 minus 1, which is going to be 1.5, which is equal to 3 by 2, which means 2 cups of pure milk and 3 cups of water. So this is going to be the option B. Clear? What is that B? 3 cups of water to 2 cups of pure milk. I hope it is clear. You can write the water first and milk also like that. Is that clear? The option is B. 2 cups of pure milk and 3 cups of water. Going to the question number 26. Freezing point of 4% aqueous solution of the X is equal to freezing point of 12% aqueous solution of Y. If molecular weight of X is A, then molecular weight of Y is. So again the same thing, delta TF of X is equal to 1000 by 100 4 by A into Kf. Delta TF for Y is equal to 12, or you can write 1000 by 100 into 12 by My. molecular mass of Y into Kf. So equating the similar terms here, you can write 4 by A is equal to 12 by My, which is nothing but My equals to 12A by 4, which is equal to 3A, which is option B. I hope it is clear, which is option B. I hope the problem is clear. Similar one you had solved earlier also, the 20th one. Then coming to the question number 27. 1 gram of non-volatile non-electrolyte solute is dissolved in 100 gram of two different solvents A and B. So here whose ebullioscopic constants are in the ratio of 1:5. The ratio of the elevation in their boiling points, like that it has been asked. So delta Tf of A is equal to 1000 by 100 into 1 by m2 into 1. Delta Tf of the B is equal to 1000 by 100 into 1 by same solute, so m2 into 5. So when you are going to take a ratio, delta Tb of A, it is depression in the boiling point, ebullioscopic constant. So you can take this as B, and this is B. Delta Tb by delta Tb of B. Please consider this as elevation in boiling point, delta Tb, okay, which is equal to 1 by 5 or 1:5, which is option C. I hope it is clear. Coming to the question number 28. Elevation in boiling point for 1 molar solution of glucose is 2 Kelvin. The depression in freezing point of 2 molar solution of glucose in the same solvent is 2K. The relation between Kb and Kf. So what you can write? Delta Tb is equal to m into Kb. So this is 2, this is 1 Kb. Similarly, delta Tf is equal to m into Kf. This is 2, this is going to be 2 and Kf. So Kf is equal to 1. In this, Kb is equal to 2. So Kb is nothing but 2 into 1, which you can make it as 2 into Kf. So Kb is equal to 2 Kf, which is option B. I hope it is clear. You can solve in different ways also, where you will end up with the same answer, where Kb is equal to 2 Kf, which is option B. Okay, going ahead with the 29th question. An azeotropic solution of two liquids has boiling point lower than either when the boiling point is lower, vapor pressure should be lesser. Clear? Vapor pressure should be higher, which means the solution should show a positive deviation from Raoult's law. So the option C is the correct one. Clear? Option C. Higher vapor pressure, when it shows the positive deviation, boiling point will be lesser. Okay. Going to the question number 30. Match the following. So vapor pressure of pure solvent is an intensive property. There are no options given, so you can just mark them. Pure solvent is an intensive property. Clear? Because for a solvent, the P naught value is same. Then delta H, extensive property. Delta Tb, colligative property. And azeotropic of the water and ethyl alcohol forms a constant composition mixture. So that is about the, you can write 1Q, 2P, 3R and 4S. Clear? I have marked them. You should be able to make out. Then question number 31 on the same lines. Match the following. Gas plus water solution, which will have the option yes for 1 it is S. I will tell you why. Okay, then 2 it is going to be P. For 3 it is going to be the Q. Clear? Here gas plus water, delta H is less than 0 because dissolution of gas is a exothermic process, and delta S is less than 0 because when gas dissolves in water, randomness decreases. I hope all of you know gas maximum randomness, then liquid lesser, then much lesser in solid. So when gas dissolved, delta S is less than 0. Then sugar in water solution, P, because sugar dissolves and the heat is absorbed there to overcome the forces of attraction between molecules, delta H is greater than 0, and delta S is also greater than 0 because sugar from solid to liquid, the randomness increases. So delta S is greater than 0. Then saturated solution plus solid. Saturated solution is one where no more solute can be dissolved, so concentration will not change. So delta molality is equal to 0. Whereas delta H is greater than 0 for the endothermic formation of solution. Is that clear to you? Okay. Going to the question number 32. Two aqueous solutions S1 and S2 are separated by a semi-permeable membrane. Solution S1 has got greater vapor pressure than solution S2. So water flows from, so whichever has the higher vapor pressure has more solvent, which means it is a dilute solution. Clear? So in that way the option is going to be A. Clear? And you have to remember the more solvent, S1 more solvent, high vapor pressure, and solution is dilute. S2 less solvent, low vapor pressure, and it is concentrated. So osmosis from low concentration solution to high concentration solution. High concentration solution. That is why the option A is correct, from S1 to S2. Is that clear? Okay. Going ahead with the question number 33. The relative lowering of vapor pressure produced by dissolving 71.5 gram of a substance in 1000 gram of water is 7.13 into 10 to the power of minus 3. The molecular mass of the substance will be. So how you write the formula? P naught minus P by P naught. Clear? Which is RLVP. The formula is W2 by M2 into M1 by W1. Clear? So in this, the data given for the relative lowering of vapor pressure 7.13 into 10 to the power of minus 3. W2 is 71.5. M2 you have to calculate 18 molar mass of water. 1000 it is going to be for gram of the water. So M2 when you calculate, it is going to be 71.5 divided by 7.13 into 10 to the power of minus 3 into 18 by 1000, which comes out to be 180.5, which is going to be option A. You have solved earlier also similar problems. It is of the same sort. Okay. Going ahead with question number 34. A solution of 1.8 gram of glucose in 100 ml of water will freeze at, so they have asked for the freezing point of a solution. Given Kf of water 10.8. Do make the correction, it is 1.86. Otherwise none of the options have that value if you take it for 10.8. Okay. So the formula delta TF is equal to 1.8 divided by 180 into 1000 by 100 into 1.86. I hope all of you remember the formula. Delta TF, it is nothing but mass of the solvent, which is going to be 100, mass of the solute 1.8, its molar mass 180 because it is glucose, 1.86 is Kf. So when you calculate this, delta TF comes out to be 0.186. Calculation is very easy there. Okay, then delta TF is nothing but TF naught minus TF. You have been asked to calculate TF, which is 0 minus of 0.186, which comes out to be minus 0.186 degree centigrade. Is that clear? So which is going to be the option A. It is option A. Is that clear? Going ahead with the question number 35. The boiling point of a solution of 0.11 gram of substance in 15 gram of ether was found to be 0.1 degree centigrade higher than that of the pure ether. The molecular weight of the substance will be given Kb 2.16. So 0.1 equals 1000 by mass of the solvent 15, W2 0.11, molecular mass you have to calculate, and Kf is 2.16. Since they are all MCQs, formula writing is not essential, so I have not used anywhere the formulas. You should be thorough with the formulas and the data where to substitute. Clear? So M2 comes out to be 0.11 divided by 0.1 into 1000 by 15 into 2.16, which comes out to be 158.4, which is option B. Is that clear? 158. Easy calculation, you are able to do it. Coming to the question number 36. The osmotic pressure of 1 nim solution at 300 Kelvin is. So what is the formula? Pi is equal to RCT. Clear? And the solution concentration is 1 m. So R 0.0821 into C 1 into temperature 300, which comes out to be 24.63 atmospheres, because you have substituted R as atmosphere liter per Kelvin per mole. So it is atmosphere, which is option B. Clear? I hope the problems are clear to you. You solve similar problems, more practice, and you will be thorough with the things. Okay students? Okay, see you.